All right, we're going to talk a little bit about Pascal's triangle. Discovered by mathematician Blaise Pascal. Actually, first of all, the name Blaise is awesome. If I have another kid, I think I'm going to name him Blaise. I'll run that by my wife. What do you think? She says no. Sorry, never mind. Backtrack on that. But he was way behind other mathematicians who discovered it. So he took the findings of others, developed it. So I think because he developed it and put it in a way that we can all understand and access is probably why he got so much of the credit. But anyway, Pascal's triangle. What is it? First, you put a 1 down up top. So you always are going to start and end with 1s. And then you put a 1 here and a 1 here. So far we're kind of boring with all 1s, and we're going to start with a 1. But then how you make rows is you add up the 2 numbers right above it. So the 1 and the 1 added up makes a 2, and then you end with a 1. End with a 1, add them up for 3, and then this makes another 3 with a 1. So here we start with a 1, then here we have 4, 6, 4, and 1, 1, 5, 10, 10, 5, and 1, and I'll do one more. Well, I guess I think I'm kind of out of room. Okay, so Pascal's triangle, and you could obviously keep this going forever and ever. Well, at first you're like, well, that's just a blob of numbers. That doesn't really help me very much, but there's actually a ton of really interesting math loaded up in this one little triangle. So there's a few properties about it. The first property that we're going to say is that the row number is the second number. Oops, if I could spell, the second number. And that's important. Right up here, we're actually going to call this row 0 up top. Because if you call that row 1, all the rest of the properties don't work out so well. So the second number is a 1, so this is going to be row 1. The second number is a 2. This is row 2. I think you get the idea. 3, 4, and this is going to be row 5. So if I say find the 5th row, it's the one that has 5 as the second number. Okay. The next thing that we can see is that each row is symmetric. Meaning, if you find half of it, you're done. You don't have to keep calculating terms. So if I ask you to find row 4 and you found 1, 4, 6, well, you'll say, oh, I know it's symmetric. It's go 4, 1. Okay. If n is the row number, each row has n plus 1 terms. So row 1 has 0 plus 1 terms. Row 0 has 0 plus 1 terms. Row 1 has 1 plus 1 terms. There's always going to be one more number in the row than that number. Well, let's get into some of the more interesting stuff. So really, if you notice, watch this. If I add up this row right here, add up that row, you get 1. 1 plus 1 is going to be 2. Row 2, add this up, and you're going to get 4. Add this up for 8. Add this up, and you're going to get, looks like 10, 14, 15, 16. And maybe you can see, look at, we have our powers of 2. It's doubling over and over again. Not only that, this is row 0. This is going to be equal to 2 to the 0. This is row 1. So this is going to be equal to 2 to the 1. Row 2 is 2 squared. So if you go 2 as the base to the power of the row number, you're always going to get the sum of the row. So sum of each row is 2 to the n. Kind of nice. The last thing, and this is probably what I consider the most amazing thing, is these are also going to be all your combinations. Watch this. If I go on my calculator, and let's just try to calculate row 5, and I'm going to hit math, and not do permutations, but combinations. I'm going to go math, I'm going to go over to probability and pick combination, and I'm going to go 5. Now, I'm going to always start out with choosing 0. That's another thing. Just like this is row 0, you got to start out with choosing 0. 5 choose 0 is 1. Not very interesting. But if you hit second and enter, you get that back. 5 choose 1 is 5. So here, second, enter. 5 choose 2 is 10. 5 choose 3 is also 10. And then you can probably imagine how this is going to go. Math probability, oops. 5, choose 2. Oh, I already did that one. 5, choose 4, I meant to do. 4 is down to 5. And then 5, choose 5. So each row are all your combinations of that number. Row elements are your combinations of the row number. Okay? So right here, I want you to find the 9th row of Pascal's triangle, and we're going to use properties. Well, what you could do is draw out your triangle and then just keep adding them together until you get row 6 and then row 7. But first of all, we can say, all right, the 9th row, I know that there's going to be 10 numbers. That's what I'm looking for. There's 10 numbers in it. I also know the first one is a 1 and the last one is a 1. So I've got 2 of them down already. Then I know there's going to be a 9 and there's going to be a 9. So I'm looking really for 3 more numbers. Now, the next thing that I can know is that this is 9, choose 0, 9, choose 1. Let's do 9, choose 2. So I'm going to go on my calculator, and let's go 9, choose 2. And we can say 36 is going to be the next number. If that's a 36, this is a 36. And then let's go 9, choose 3. Got an 84. This is an 84. So there's 8 numbers. I'm looking for 2 more numbers. And let's go 9, choose 4. 126. So we have 126 and 126. Okay, so using properties, it really wasn't so bad. It didn't take us all that long. Find the sum of this. Well, what you could do is write them all down and add them up. Or we could just go 2 to the 9th power. 2 power 9, 512. Easy enough. Find the 3rd term in the 12th row. Okay, well, it does help to write things out. So your first term is 1, your second term is 12, and now I want to find the 3rd term. Well, I don't want to write out all the rows, but remember this is 12, choose, got to be careful, this is 12, choose 0, 12, choose 1, and this is going to be 12, choose 2. So math, 12, math, go to probability, 12, choose 2 is going to be 66. And you got it. An interesting application of this is that if a coin is flipped 8 times, what's the probability that heads is flipped exactly 5 times? Well, let's take a second. Maybe I'm going to write out row 8. Okay, so there's going to be 1, 1, 8, 8. After that, I'm going to go 8, choose, math, choose 0, 1, choose 2. So we've got 28. 28. Let's see. Choose 3. 56. And 56. And let's see. There should be 9 numbers, so there's 4 here, and there's 4 here. Let's do one more. Choose 4. Got 70. Okay. So if a coin is flipped 8 times, here's all the different things that can happen. So if we're going to get heads exactly 5 times, well, that's actually a combination because it doesn't say that you get heads the first 5 times or the last 5. So the order doesn't matter. It doesn't matter when you get those 5. So if I'm looking at this, we can have 8, choose 0, 1, 2, 3, 4, 5. So there's 56 ways that you can get that you can get that 5 times, flipping 8 coins. And then now the denominator is the total number of ways that you can do anything. That would be 2 power 8. So 2 power 8, or you could just add up all these. So we're going to go 56 divided by, oops, let me try that again. 56 divided by 2 power 8. And you'll have a 21.9% chance. So Pascal's triangle can help you out with probability as well.